Good morning and welcome to Map Skills Latitude and Longitude Edition. Here's where we're going to find out about all those lines intersecting on our maps. Latitude is the first line you need to know about. I like to use the rhyme flatitude to help me remember that these are the flat lines on your map. They're measured north and south from the equator. The equator is the most important line of latitude, and it is at 0 degrees right in the center of the Earth. It is the longest line of latitude, and it is the circumference of the Earth. Some other important lines to know about: 23.5 degrees north and south, those are your tropics. You need to also know about 66.5 degrees north and south, those are your Arctics. The Arctic in the north and the Antarctic in the south. 90 degrees is a pole at the north or south, and you need to remember that it is a point, not a line. So when you see 90 degrees north drawn as a line across the top of a map, that is where the most distortion will occur. If you see latitude lines, they are always parallel and thus are referred to as parallels. You can go to the 30th degree north parallel, or you can go to 30 degrees north latitude, and you'll be in the same place. Let's nuance latitude a little bit. Find out what exactly this is telling us. Latitude is going to impact climate. The lower your numbers are, the hotter your climate's going to be, because you're at the center of the Earth, which is a sphere, and that is the part that is closest to the sun. As you get to higher numbers, you are going to be tilted away from the sun, and you are going to get colder climates, up to 90 degrees. Remember that you cannot go higher than 90 degrees in latitude, because that is the way it is measured, and 91 degrees would take you off the Earth into space. Notice that elevation is going to trump latitude, because a higher elevation has thinner, colder air, like the Himalayan mountains. It's going to be super cold even though we're close to the equator. Latitude lines are always measured north and south of the equator, so while they're drawn across a map, they are not and cannot ever be east or west. Let's talk about longitude. I like to say longitude to remind myself that these are long, skinny strings of spaghetti. These are going to be measured west or east from the prime meridian, which is again one of your most important lines of longitude. It is the 0 degree line of longitude that runs from the North Pole to the South Pole through Greenwich, England. Now, the interesting thing is, while the equator can only be in one place, the prime meridian really could have been anywhere, and it just so happens that humans decided Greenwich, England, for a whole host of different reasons. Halfway around the globe from the 0 degree line is the international date line. It is the highest number that you can go in longitude, 180 degrees. When you see it drawn on maps, it is often drawn in a zigzag pattern because it is connected to time zones and the date, which is why it's called the international date line. And we don't want to have half of an island being Monday and half of an island being Tuesday. Imagine all of the chaos that would create getting to your dentist appointment on time. These lines are all going to touch at the North and South Pole. Therefore, they are referred to as meridians of longitude. These lines cannot be called parallels, and so when you hear the term parallel, it is only referring to latitude. And when you hear the line meridian, it is only referring to longitude. So let's nuance this longitude idea a bit. Longitude is going to impact the time zone that you are in and whether you are in day or night, because it is going to spin around as the Earth spins around, and sunshine is going to be shining on only half of our sphere at a time. That's going to impact whether you are in daytime or nighttime. The more curved that you see these longitude lines on a map, the less distortion that you're going to have. If you see straight lines of longitude in a world map specifically, then the most distorted areas again are going to be at the North and South Pole along the top of the map. Remember our friend Bob and his hair and chin and the distortion that was resulting. Remember that these lines cannot be larger than 180 degrees, nor can they be measured as north or south, because we are heading east, or west of the prime meridian, that main line where all of the numbers start from. So, if we want to get to a little bit deeper understanding, this is a bit more mathematical perhaps, of how these numbers came about. They're measured from the geometric angles in relation to both the equator and the prime meridian. We have latitude over here and we have longitude over here. So notice that I'm measuring from my 0 degree, if I was drawing this on a graph, and here's my x and y axis, then if I were to take an angle and measure it from the center of the earth, that angle, which is, this is a 30-degree angle, where that angle intersects with the edge or the outer crust of the earth is going to be where my 30-degree line of latitude appears. And then if you were to imagine this as a 3D image, that angle would extend in a circular pattern all the way around the earth, all the way up to my 90-degree angle, which is going to be the North Pole. That's why when you see these drawn on a map, your numbers are going to appear on the right or left side, even though you're measuring north, like a ladder, or south of the equator. Your latitude lines are not going to be numbered across the top of the page. Longitude, on the other hand, is measured from the center of the earth out to the edges, and we're actually measuring a half circle from 0 to 180 degrees, rather than in latitude where we're measuring a quadrant up to 90 degrees. So you're going to notice that your North Pole, which is here at the center, I'm imagining I'm looking down from the top of the earth, and my North Pole and my 0 degrees, here's my angle measurements that I'm getting, and then again as that line goes out to the edge or crust of the earth, that's where my 90-degree mark is going to go, from North Pole all the way down to South Pole. And when I see these lines drawn on a map, I'm going to see the numbers labeled across the bottom, because this 95 is indicating this line that is running vertically, and it is measuring the number of steps or degrees east of my starting point at the prime meridian. With that deeper understanding and some of the basic skills, we can now understand that a city like Moscow, which is located at almost 60 degrees north, is going to experience some very cold climates because it is at a higher latitude, whereas a city like Mexico City, which is located at approximately 21 degrees north, is at a lower latitude and therefore in the tropic zone. So I can see how latitude is going to affect my climate. Then I can also see how longitude is going to affect my time zones, so that a city like London is going to be in a similar day-night pattern to a city like Madrid, but on perhaps different time of day from a city like Vancouver. Same climate and latitude, different time zones, based on whether the sun is shining on this half of the earth or this half of the earth. If you have any other questions about latitude and longitude, please refer to the resources that you have available on your Haiku page and also in your Shobi folders. Thanks, and have a wonderful afternoon.